Hi, my name is Lingi Soren and I am from group B3, and me and my group are going to present about the design and performance analysis of low power CMOS op-amp. So going on to the introduction, we will be designing about the low power CMOS op-amp with a two-stage amplifier. So as for the introduction, our idea is to design a low power or operational amplifier and check its analysis performance, and also for us to design a two-stage amplifier and form the required analysis for us to compare with the research paper that we obtained previously. So as for our objective today is to design and simulate the low power CMOS operational amplifier using LTSpice software. So in the software we can design the CMOS circuit using the NMOS and PMOS, and we can also simulate for all the required analysis waveform. So as for this simulation, we are going to analyze the DC, AC and transient analysis waveform.
Hi, I am Kavin Raj, son of Mongredas, and my metric number is 2010-31469. Now, I am going to explain about the flowchart of our mini project. First, we design our circuit in LTSpice software. Then, we set the parameters that involve in the circuit, such as the values of voltage supply, load capacitance, and other relevant values. Then we start our simulation. At first, during our simulation, we are unable to obtain the waveforms. So we redesign the circuit by verifying the connection and stimulate again. Now the simulation is successful and we are able to generate the waveforms for AC, DC and transient analysis.
Assalamualaikum. My name is Haris Putri. For this project, I am responsible for designing the entire schematic diagram. So what we are looking now here is the layout that I have designed based on the article that we chose. I also created a multiple save file for separate type of analysis for ease of access. Okay, so first off, this is the DC analysis. For DC analysis, I remove the transistor over here and replace it with a current source. I also insert a new command to run the DC analysis. The command is as shown. Okay, so next we have AC analysis. For this analysis, the layout is still the same, only that I add another path over here, and the command for this analysis is as shown here. Okay, and lastly, for the AC transient analysis, still the same layout as AC analysis. The only difference is the command to run the analysis. This is the command. Thank you.
As for the DC analysis circuit, as you can see, this is the circuit that we designed for our two-stage operational amplifier, and we give a VDD of 1.8 volts and VSS of negative 1.8 volts for us to set the limit of the waveform. And also there's a positive input of sine wave which has a 180 degrees phase shift, and a negative input of sine wave 2 with 0 phase shift, which both has a 1 volt amplitude and 1 kilohertz frequency. So for the DC analysis, we actually made a DC analysis with the linear analysis with negative 5 milliseconds of start time and 5 milliseconds of stop time with 0.1 milliseconds of increment. So with this, we actually get the waveform of this as below. So this is the DC analysis waveform, which the green one is the output voltage with the saturation point over here, and we have the blue line is the input voltage of positive on the operation amplifier. So the Q point is labeled over here, which has a negative 87.3 microvolt and negative 87.3 microvolts as the Q point of this simulation. So that's all for my part. Thank you.
Warahmatullahi wabarakatuh. My name is Muhammad Sani. My number is 211-0326-96. So my part is I want to explain about transient analysis. This is transient analysis waveform in circuit. Transient analysis determine a time domain where its parameters such as voltage and current is plotted against time. Transient analysis analyze change in voltage and current over time when an input signal is applied in circuit. If looking at an output waveform, we can see the behavior over a specific length of time. Based on waveform, we are going to simulate the output of a two-stage op-amp. We got output waveform is the same with the paper reference. A step from ground to VDD applied at the input the unity feedback configuration for rising edge of pulse and falling edge of the pulse is obtained.
Now, I'm going to explain about the waveform of AC analysis. During AC analysis, we choose the type of sweep as decade, the number of points as 100, the frequency start from 1 and end at 100 MHz. The DC gain that we obtain from the graph is negative 157 dB and the phase is 170 degree. The values of both DC gain and phase can be obtained by analyzing the intersection points between the two waveforms. We compared the values with the article. While comparing with the article, the values are different because of the unavoidable reasons.
In conclusion, the design of lower CMOS operation amplifier using Altispice software is successful. The DC, AC, and transient analysis waveform is obtained and compared with the previous research. Learn more about CMOS and its parameters that highly affect the circuit outcome. Thank you.